So yeah, in this webinar, folks, we are going to show you how Gen AI audio companies can use TransparentMeta to comply with AI transparency law. And I'm Valerio Velardo, and I'm the co-founder and CTO of Transparent Audio. So let's get started straight away. Before jumping into the actual content, I just wanted to give you an overview of what we're going to be touching. So first of all, I'm going to give you a little bit of the context for what TransparentMeta is and how it came into being and what kinds of problems it solves and for whom. Then we're going to see a hands-on tutorial. It's going to be quite quick, quite fun, very simple stuff, really. And I'm going to show you how this works in Python. And then we're going to move on, and I'm going to share some resources that you folks can use to just dive deeper into TransparentMeta. And then we're also going to be talking a little bit about what we are trying to build next, because it's a whole suite, as you'll see, of connected products that will be building what we call the open source trust layer of generative audio. And finally, we'll leave time for questions for QA, so you can ask whatever you want. Okay, let's get started. So I think you might have seen this video before, and that is an audio and video deepfake of Zelensky basically saying that, all the Ukrainian army should stop fighting, and that was at the beginning of the war, and it was just a deepfake created by Russian propaganda. That's all it was. So we are living in a moment where audio deepfakes are mounting and mounting, not just audio deepfakes, but also video deepfakes. And really what we are saying is that a lot of AI generated content is being shared as we speak on social media and across all the places possible. And that is a problem because at some point it becomes very difficult to understand what's true and what's fake. It's very difficult to distinguish the two things. And so what is the solution? Well, the solution is to mark audio content as AI generated. Now, this is the kind of solution that we came up with TransparentMeta, but it's not just us. Basically, this is a proposition that comes directly from a bunch of institutions and regulators all over the world. And so there's a growing layer of output transparency law. For example, in the European Union, we have the AI Act, and in that act, that basically covers a lot of ground for AI regulation. There's a particular article that's called Article 50, and then specifically Section 2, that says that all the AI-generated content should be marked as such, and the responsibility lies on the generative audio provider. Well, of course, this legislation is not just about audio, it's about all modalities out there, but it is important to understand that's also for audio. But the EU is not the only actor regulating transparency and AI transparency. There's also a similar act in California that's called the California AI Transparency Act that's very similar to Article 50, Section 2. And there's also a Council of Europe Convention on Artificial Intelligence where transparency is mentioned as a very important point. And the signatories there are basically 95% of all the Western countries. So it seems that transparency law for artificial intelligence is growing at a very huge speed. Now, this is not just a suggestion. So, for example, here in Europe, there are big fines for non-compliance. And so once the legislation gets enforced, and that will happen in August 26, all the providers that don't comply with this legislation, with AI transparency law, are going to be fined what's higher between 7% of their annual revenue and $15 million. So it's a huge, huge problem. And it's important that Gen AI audio companies try to address it like as soon as possible. And I would say not just like because it's a fine problem, but because also like it carries a huge like ethical problem with it. Okay, so how can we address transparency in the output side for AI-generated content? So what are the different solutions? Well, we have like different techniques: the metadata, watermarking, and AI identification. So watermarking is basically just injecting some information hidden in the zeros and ones of an audio file. AI identification is basically having a classifier AI model that listens or processes an audio file, and it can tell you whether or not like this audio file was generated with a model and with what model, right? And then we have obviously metadata. And of course, we released TransparentMeta. So of course, like with TransparentMeta, we're dealing with metadata, and we're going to be zooming into metadata quite a lot throughout this presentation. Okay, but what's TransparentMeta in the end, right? Well, it is, we like to say it like as sort of like new standard for AI transparency compliance in AI audio. And we're building this while we're also advising the AI office. That's one of the it's like the main office like responsible for artificial intelligence legislation and regulation in the EU. So basically, we are like one of the stakeholders who's like kind of like connected with the AI office, and we are giving feedback, suggesting possible solutions, and also like understanding what's going on. So all of this to say that we are like very well connected with the regulators. And so we try to use all of the information that we receive in order to build tools that are as compliant as possible. Okay, and this is who's behind Transparent Audio, the whole company. So that's Lucas, my co-founder and CEO, who has a very long career in audio, specifically music tech. He's been around audio tech like for 15 years, and he's worked on multiple startup companies, and he's also basically built different like audio products, like music products, and he has a background as a product manager and a strategy leader. And he's also has strong connections with the open source community. Myself, I'm the CTO, so I deal with the technical part, and I have 15 years, perhaps a little bit more in AI audio, AI music, generative music. And I founded and sold a generative music company before it was all the rage, unfortunately, and it was called Melodrive. And yeah, we started like that venture back in 2016 and sold it in 2019. I'm adjunct professor of generative AI music at the Music Technology Group at the University Pompeu Fabra. And perhaps like some of you may know me through The Sound of AI, which is basically one of the biggest online audio AI ecosystems with a YouTube channel, a Slack channel as well. And I've been a consultant for dozens of AI audio tech companies all over the world, and also have been head of AI and MLOps at multiple companies. And I have a PhD in AI music. So all of this to say like that we are like very well invested like in what we're doing, and we know our way around the problem and the possible solutions. Okay, so now let's go back to TransparentMeta. So what's TransparentMeta about? Well, if we want to go like down to the details, TransparentMeta is a Python library to write, read, and verify transparency metadata in audio files. It's basically as simple as that. So these are the principles that we've used to develop TransparentMeta. We wanted for TransparentMeta or any other products that we will be building to be compliant, to be open source. We are strong proponents of open source, and we think that in order to have trust from all the stakeholders in the industry, these products should be as open as possible. And so that's why we're pushing for all of our products to be open source. They should also be extremely easy to use, because at the end of the day, generative AI audio companies don't want to care that much about AI transparency legislation and implementation, all of that. It should be really plug and play. But at the same time, this should be secure and minimalist. Why minimalist? Because there are other solutions out there, for example, in metadata, that more or less already exist, but they are way more complex and they carry way more information than the necessary one that we need for comply with AI transparency law. So these are our development principles. And as I said, we release these products as open source, and we use the GPL v3 license that's really free, as in freedom. So all you see today, you can use it for free by yourself, and you don't have like to pay us a cent. Okay, cool. So now let's take a look at TransparentMeta features. So with TransparentMeta, with this Python library or SDK, however you want to call it, you can write transparency metadata. You can read and verify transparency metadata, and all of this is cryptographically signed. And this is connected with the development principle of security, of like having something like that secure. I'm going to dive deep into this a little bit later. And you can also basically like build your own key pairs for signing these metadata cryptographically. Okay, so what problem does this solve? What problem does TransparentMeta solve? Well, AI transparency compliance, or at least like it's the first step in AI transparency compliance. And as we'll see, for AI transparency compliance, there's more than just metadata, but this is the first step of the ladder. And it solves the problem of having secure metadata you can trust. And it, as a side effect, it also solves copyright attribution. Now, for those of you who are in music, probably you know what that problem is. And the problem is that we want to know who owns what of a piece of music. Like, for example, I want to know that the lyrics was created by Lucas, that Valerio created like all the musical accompaniment. And then there was, I don't know, like a James who actually performs on all the instruments. And we want to know all of that information. And so we can basically bundle all of that information into our transparency metadata, as we'll see in a second. Who should use it? Well, everybody who's in dealing with audio, they should basically use this, but specifically generative audio companies, or companies that deal with generative audio in their like day-to-day operations. And so these are like text-to-speech companies, voice cloning companies, generative music companies, or voice companies, or companies that deal with music data. So as long as there is like some audio, using TransparentMeta is a very good idea. Okay, so how does it work? The workflow, it's very, very easy. So initially you generate a key pair. So you're going to end up like with a private key and a public key that you'll use for cryptographically signing the metadata. And we'll see what that implies and what are the benefits of that. But once you have these keys, you can then write and sign the metadata for an audio file. And then at verification time, you have facilities for reading and verifying the metadata through the signature. Now let's dive into like these different use cases. We'll ignore writing, generating keys for now. We'll see how we do that like directly in code. But I just wanted to give you a high-level understanding of the writing and reading side with a simple diagram. So we start with an audio file. In this case, it's an MP3. It could be a WAV file. For now, TransparentMeta handles only WAV files and MP3s. The idea is to extend to other audio formats, but for now we are like bare bone on MP3 and WAV files. So once we have our audio file, we come in with our transparency metadata. Then we use our private key. So we get like this metadata. We write it into the MP3, and then we sign it with the private key. And what we get is basically the same audio file, but now with metadata that's been signed, and it's basically ready to be shared like all over the world and on the internet. And indeed, what we have is basically a couple of tags in the MP3 metadata, and one is called metadata, and the other one is called signature. I think like there may be like an error here, a mistake, because one is called transparency, and the other one like is called signature, if I'm not wrong. Okay, so but where do we actually put this metadata to? Well, we put them into ID3 V2 version 2 tags, and these are tags, metadata. This is kind of like metadata, like information, and it's a format that's used natively in MP3s. But we basically do the same thing also like for WAV files. We create a sort of like custom ID3 V2, and in there we create like two custom tags, one called transparency and the other one signature, right? And we basically store the transparency metadata clear. They're not encrypted, but then we have the signature in another tag. So we are talking about transparency metadata, but what are like these metadata in the end? Well, this is like the data structure. Like it's quite self-explanatory, right? So you have to put the information about the company that came out like with that audio file, that generated like that audio file, the model that you've used, when it was created, the AI usage level. There are different, for the time being, we have 3 levels. So level 0, it's basically like human created. Then we have AI assisted. That's the one that you are seeing here. And then there's a third one that's fully AI generated. Perhaps like in the future, we're going to be a little bit more granular with this. But for now, we only have like these 3 options that are good enough. Then a content ID that you can put in, and the user ID, so that you have an idea of like who did what. Of course, like this is not like the username for previous reason. It's just like an ID, right? And then you put in like your private key ID. Well, that's not obviously like the private key itself, because that's private to you. But this is the private key ID, so that you know which private key you've used, so that at reading time you can retrieve the associated like public key associated to that specific private key. Okay. And finally, you have a custom, like completely optional field that's called additional info. And in here, we suggest that you can plug in copyright attribution information following this pattern, right? So you create like an attribution field, and in here, you can put whatever information you want. For example, lyrics was, the lyrics like were created by John Doe, and the composer behind this was Jane Smith, and perhaps the performer was like, I don't know, like HAL 9000 or whatever, right, an AI. So you get the point, right? So with this transparency metadata, you can also inject copyright attribution information if you want to. Okay, so now let's move on to the reading side. We have an MP3 file that's been written with our transparency metadata and signed. Now, what do? Well, we extract like those 2 tags from the ID3 B2 metadata. We get like metadata. Well, again, it's not metadata here, it should have been like transparency. So we get like transparency and signature, and then we use the public key, and we use it so that we can verify that the metadata hasn't been tampered with, right? So that the metadata, like it's still like completely secure. So, and what we get back basically is this metadata information here. That's all we need to have in order to understand like the provenance like of this audio file, and like how it's been like created, and by whom or by what, if it's a machine. And obviously, this is like mainly for machine created content. Okay, so we were talking about this cryptographic signing, right? And so what does that do? Well, it actually ensures trustworthiness, right? So basically, signing with a private key and then checking with a public key, what it does, it just like tells us whether like the audio, well, the metadata, our transparency metadata has been tampered with. So we cannot tell you how it's been modified. But what we can tell you using cryptographic signing is that data has been tampered with somehow. Perhaps like a nefarious actor came in and they swapped they flipped a number like in the metadata, or like they changed like anything, right? Or in the signature even, right? If that happens, basically we're going to be able to say, hey, no, this metadata is no longer trustable, and so just ignore it. We cannot use it for now, okay? So this is how we make TransparentMeta super secure and tamper and be able to identify all the type of like tampering like that can happen there. Okay, so we had like a few people already like playing around like with TransparentMeta. For example, Anmol, who's an AI developer, and he had like great experience with it. He said like, yeah, this is super smooth installation, great setup, and code is well structured. And here's another developer, Fernando, who told us, yeah, TransparentMeta is easy to use, clear documentation, and its plug-and-play nature is always what I'm looking for in Python libraries. Okay, so basically all of this to say like that, yeah, the library like is resonating like really well with the community. Okay, so now let's move on to the hands-on tutorial. It's going to be like quite quick, the whole thing. But what I want to show you are like the basic things that you have to know. So how to install TransparentMeta, how to generate a key pair, how to write metadata, and how to read metadata. So now, installation, it's done via pip because TransparentMeta lives directly in PyPy. But you'll have to have like Python 3.12 or above. Okay, so now I'm going to jump into my PyCharm session. And so you should be able to see my PyCharm. So this is TransparentMeta, okay? This is the library, and this is a terminal. So in order to install TransparentMeta, what you have to do is simple pip install TransparentMeta. That's it. You do that, you run it. In my case, it's not installing it because it's already installed, but basically like it would just like get TransparentMeta from PyPy and install it with all the dependencies. So that's all you need to do if you are a user of TransparentMeta. Okay, so now let me show you how to do like these three things. So generate a key pair, write metadata, and read metadata. So we have directly in the repository an examples directory, and here we have like all sorts of examples like that you can just like check out. And so we'll start from one of this that's called generate a key pair. And so basically what we do is we generate a private public key pair. And basically, like for all this cryptographical signing, we use a state-of-the-art algorithm that's called ED 25519. It's a weird name, but I assure you, like that's the industry standard for this kind of stuff. So then, once we do that, like we'll save the private key to a PEM file, and we save the public key to a PEM file. So what do we do here? Well, you can go in TransparentMeta. There's a sub package there that's called Crypto, and that has a key management module. And from key management, you're going to import these three functions: to generate key pair, save private key to PEM file, and save public key to PEM file. So here we have like a simple main. So as you can see, we get the private key and the public key just by running this generate key pair, and then we pass the private key and a private key path where we want to store the private key. to this function called save private key to PEM file. I mean, that's kind of like, it does what it says it does, okay? And we do the same thing with save public key to PEM file. Okay, so now I'm going to run this script. We run it, and as you see here, like there's all the logging, and yeah, so we generated a new key pair, we saved it, and we saved the private key, and we also saved the public key. Fantastic. So that's how you create like your keys. Okay, next step. We now want to write some metadata. So how do we do this? Well, first of all, we have to load the private key from the PEM file. That's like the private key that we just generated. Then we need to build a transparent metadata writer instance. So that's the object that's responsible for doing the writing. And you can think of it as a very high-level interface, and you'll see it's super easy to use. Then we create a metadata dictionary with usage details and attribution, and then we'll write the metadata and signature into the target MP3 file. So now let's take a look at like what we should see here. So the first level is we're going to get like this from entity, like a metadata AI usage level. And so I'm going to jump in here just let you see what this is. Okay, so this is AI usage level. It's an enum, right? I mean, these are like the three levels like that we had, right? So AI generated, AI assisted, and human created. So that you have like some context, right? Then we get like from the SDK a factory function. That's a function that generates that instantiates a transparent metadata writer, and it's called build transparent metadata writer. So what do we do here? Well, first of all, like we load a private key from PEM file, and we pass the private key path. And by the way, like this one, I guess, like yes, we import from key management, right? It's the same module that we had for the generate key pair use case. Okay, so we get the private key. Now we instantiate a metadata writer with like this factory function. And so we pass the private key so that the transparent metadata writer knows which private key to use already. And this is the transparent metadata writer object. And then we define a metadata dictionary. That's what we saw earlier, right? So that's that data structure called company, model, with all of these fields, right? And we pass in also attribution, right? So lyrics, composer, and singer. This time, HAL 9000 is the singer. Okay, so now we have like all of this. So we take like the object, transparent metadata writer, we do a dot write. We pass the audio path, so that's the MP3 file, right? And this is just like a test audio path. I think like we import it like from here, right? It's examples like a config, so it should be somewhere here, yeah, in the config. But basically what we are passing is an audio file that's here, test.wave, okay? And then we pass the metadata, and basically we're done. We run this and we're done. So let me run this script. Yeah, and here you'll see like all the logging, but the important thing like in the end is that we successfully wrote metadata with signature to file. Yeah, and that's the file that I was mentioning to you earlier, folks. Okay, that's in data, and it's called test.wave. Okay, so now we've written like all of this, like, and we also signed it. So now we'll move on to the final use case that's now reading the metadata and verifying the metadata. Okay, so what we do on a very high level is these three things. So we load the public key from a PEM file so that we can then like verify the signature, right? So we then build a transparent metadata reader. That's basically the mirror of the transparent metadata writer object, because this one reads, right? And we instantiate it with the relative factory function, creation function, and then we read and verify metadata from the specified audio file, right? So we do like all the imports here, right? And the new thing here, it's this transparent metadata SDK. We import build transparent metadata reader. That's going to instantiate our transparent metadata reader, okay? So we get into this main, so we load the public key with this utility function, right? Passing the public key path. Now we have the public key. Now we generate an instance of transparent metadata reader passing the public key, so it's already in here, right? So the transparent metadata reader already knows which public key to use. And then we do a transparent metadata reader.read, and we pass the audio path, the path to the WAV file where we've written the metadata inside it, okay? And we get a read result. Now we're going to be printing a read result because this is an object, and it's an object that has like more information than just the metadata itself, okay? So we'll run this, okay? As you'll see, we have like all the logs, and it says like all the things like that are happening like at different times, but this is the read result, right? And so is success true? Okay. There's no error. If there is an error, then here you'll have basically like the error that you're getting. For example, the metadata has been tampered with, or the signature like wasn't okay. It's a bunch of like different errors like that you can get out here, and then you get the metadata, right? And this is an object. It's an object. It's a Pydantic object for those who know what Pydantic is. It's basically like a data class. It doesn't have like any behavior. It's only like a data structure, right? And in here you can see that you have like metadata.company, and that's the company, the model created at, like, and all the different fields will appear in here, which is nice. Okay, so that's basically it. So, and everything you'll do, so all the code here, like it's tested like 100%, and you're gonna get like all types of like errors, like an indication about like the errors that you're getting. Like, so all the edge cases are covered. So it's really like production quality code, like the one like that you'll be handling with like TransparentMeta. Okay, so now I'm gonna just go back to the presentation. I hope like this hands-on tutorial was nice for you folks. Now I'm going to mention a few resources like that you can use to dive deeper into TransparentMeta. So first of all, you have obviously the repository. So it's on GitHub, and yeah, and here you can just like clone it. And if you want, you can also fork the project, right? Because GPL v3 will allow you like to do that in case you want, or you can contribute. We're not taking like open contributions like from the community yet, but over time we're willing to do that. So if you want to contribute, by all means, like do it. And here basically you have also like a very nice like README file with all the information and everything. And yeah, remember like to start it like if you go there. Cool. So then we have also a Discord. So the Discord that we have, you can join it. And basically, this is the Transparent Audio Discord. And in this Discord, you have all the kind of like, you can ask for feedback, like for support in semi-real time. You can also ask for new features, and you can get also an idea like of having like all the announcements about like TransparentMeta, not just TransparentMeta, but also like Transparent Audio, the entire company. And Lucas, it'd be fantastic like if you could share the link to Discord. That would be great in the chat, so folks can already sign up like if they want to. And also just like prepare like the link like for the survey like later on, like that'd be great. Okay, so that's for Discord. Now we also have obviously a very detailed documentation that's on Read the Docs, and here you have like all the basics, FAQs, guiding principles, and a bunch of stuff, key concepts. So we also explain in detail what cryptographic signature is, how it works, right? And then we have learning, a lot of material for learning, of course, like the installation, but you've seen that like from PyPy, but we also tell you how to install from source code. And We have like a super simple like getting started initial like tutorial. Then we point to the examples, and then we have like tutorials that are a little bit more like in depth, like if you want to. So you have like all the levels like to really like discover transparent meta. Then we have also video tutorials. So if you are a visual learner, we basically have a playlist with a bunch of videos like that you can watch. It's probably around like 40-45 minutes, like the whole thing, and you're gonna get like the whole shebang on transparent meta by watching these videos. Okay, and finally, the last resource is the website itself. So this is Transparent Audio website, and here up in the nav bar you have transparent meta, and from here you can get like to all the other resources that I've just listed. Okay, so that was it about transparent meta. Now I just want to enlarge a little bit the discussion and bring it to transparent audio, like, and what we're going to be doing next. So one of our central ideas is to be as redundant as possible. So what this means is that we want to ensure that no matter what happens, no matter like the nefarious like adversaries like that you may have like out there in the wild, we're going to be able to provide this transparency information as much as possible. Okay, so how do we do that? Well, we do that following this principle in cybersecurity, or like security like in general, that's called like the Swiss cheese approach, right? So each approach, each layer of defense has some kind of hole, right? But hopefully, like different slices, right, of cheese will have holes in different positions, so that like this situation doesn't happen, right? So you may go through like the first layer of defense, but then the second layer of defense like catches the problem, right? Or you may go through 2 levels, but then the third layer catches the problem, right? And so basically that's what we are trying to do. So we are trying to be as redundant as possible, because none of those solutions for AI transparency works by itself, like be that metadata, watermarking, or detection, right? There's no silver bullet there, right? So you have to use them in combination, and that's what we are basically trying to do. And so on our roadmap next, what we will be building, it's a whole ecosystem, and it's not just like the tools like transparent meta, but it's an entire ecosystem that will build like trust and compliance for generative audio. So the first thing that we are working as we speak on this, it's a company registry system, and on this company registry system we have a source of truth of all the companies that are compliant with AI audio legislation, right? And there's a source of truth there, and so these companies like can register there. They know that they're basically like in the registry like of the good like ethical companies, and everybody else like can basically like retrieve information like from that company registry. After that, we'll be working on metadata and watermarking open specifications, right? And so this will be completely open specifications for metadata and watermarking for AI transparency law that everybody like can use, okay? Then after that, we'll be working on the transparent audio certificate. So now if your company implements these protocols, you're going to get a transparent audio certificate. And it's basically a badge of transparency that you can put, you can slap it to your website, just like to tell the world like that you're doing things like the right way in terms of output transparency. Then we'll be working on the equivalent of transparent meta that's going to be called transparent mark, but for watermarking. So it's going to come up in the form of a Python SDK, okay? And so you'll be able to use that. And then a centralized infrastructure. And the centralized infrastructure will basically be building like a key management system so that we can give you private key, like your private key, and we hold like the public key so that we can do a centralized trusted verification. And it is like, this is like the only thing like that we will be monetizing. So you can use transparent mark, you can use like transparent meta by yourself with your own keys, But if you want like for those keys and everything like to be centralized so that everybody will be able to verify your content, then you will be using our centralized infrastructure where we have a key management system, a trusted key management system, and a centralized trusted verification, so that tomorrow, for example, say Instagram can query us to know whether like the audio file that a user X has uploaded like is AI generated, and like what's the provenance of that. So basically, like it's done like for having like a centralized source of truth. So yeah, as you see, like this is like the map of the entire ecosystem, and the final step to that will be the third layer of defense, right? And so that's AI detection, and it's going to be another SDK called TransparentMeta. That's going to be a machine learning classification system, right? And so as you can see, we have 3 levels of defense. The first one is metadata. If that fails, we fall back to watermarking. If that fails, the last line of defense is going to be detection, right? That's going to give you a simple yes or no answer to the question, has this audio file, and was this audio file generated by this model, this generative audio model? Okay, so this is like the roadmap, and basically like we are planning on like building like all of this like different like steps or like points of the map across like in 9 to 12 months, more or less. Okay, so basically what we're doing here is not just like giving you like the SDKs, like the tools, but we are basically building the entire trust layer, and I should highlight open source trust layer for generative audio. So yeah, and so this is the product like we are developing, leveraging like our 30+ years in AI audio and like connections with the policymakers, like especially like the EU. So yeah, and that's basically like what we're doing here at Transparent Audio. And so AI transparency compliance like can seem like difficult to achieve, but it can be surprisingly easy, like if you use like what we have basically here. And of course, like I highly suggest you like that you avoid like putting off like the implementation like of all of this like transparency compliance. And of course, like you can't afford to fail AI transparency compliance, because you have to remember like the fines like that come with that. Okay, and so we have really an offer you can't refuse here, and we call it like the Godfather offer. And so basically what we are doing is giving you like TransparentMeta free, watermarking and AI detection for free, key management for free, like the whole like centralized like thing for free, the AI transparency certificate for free, and custom compliance advice, once again for free, and AI transparency alert updates for free. So we're basically giving you like all of this like for free until the AI law enforcement. So that's going to be like a year from now. So if you start working with us, so you'll get like compliant before the enforcement of the law. And in the meantime, all of this like will be for free. So that's basically like what we are offering you guys here. And we already have like a bunch of like other like Gen AI audio like customers working with us, like Kids AI, Beethoven AI, Starchild, Sample Sound, and so on and so forth. Okay. So if you're interested like in working with us and using like basically like using like the whole suite like that we're building, the whole trust layer, fill out like the survey that Lucas, I'm not sharing it, like Lucas will be sharing this like in the chat. It's a simple survey. It'd be great like if you could like fill that up like and send it over. So if we feel like there's a good fit there, like we will suggest a follow-up like strategy call where you can tell us like about like your specific use case, and we'll tell you like how we can help you with that, and we'll also like set you up like with all like your like Transparent Audio account and everything. Okay, yeah, and indeed, like on this call, we will provide you like with custom like advice, and that's specific to your case. So yeah, that's it for the presentation. Now I'd like to open the floor for questions. Cool. And I'm going to stop sharing here. Okay, folks, feel free to switch on your camera, your microphone, and just talk. Yep. If there are any questions.
I think you've got your hand raised, Jeff. You can start.
Cool. Thank you so much for the presentation, taking the time. So far, the transparent Python library has been working very great for me. So again, halfway through the quick start. I have a lot of questions, but I'll just ask a couple top level. Where can I learn more about the AI usage level definitions? And are there official definitions anywhere? Or is it something you guys are defining? I'm just curious about that.
Yes. So there are no definitions yet. This is something in progress. And so we are basically trying to predict what's going to happen, and we're quite sure that we are getting it right. And one of the reasons is because we are one of the stakeholders taking part into the conversations, and these conversations are starting in a couple of days. Really, there's going to be a workshop, and we will be present with the EU Commission, basically the AI office, really, and there we start having a conversation about the specific technical guidance and all the more technical details there. So to answer your question, there's nowhere you can read about this AI usage levels and about anything that's more specific than Article 50, Section 2 for the time being, because this is something that's been discussed as we speak. And as I said, what you can do definitely is follow our or sign up to our newsletter, because we are going to be sort of dripping information about everything we hear and everything we also suggest and push for.
Perfect. I'm just going through. Thank you. So in progress, it sounds like.
It's basically in progress, yes.
Gotcha.
If I just jump in there, it's a industry-wide discussion, right?
Of course.
To attribution and copyright attribution in music, where it's generally more complicated, right? Me and Valerio had a conversation recently with an AI head of AI at UMG, and that's one of the discussions that we had with them about how do you define AI usage levels, right? And try and standardize those things across multiple dependencies and multiple different music and voice companies and so on. So it's something that's going to be becoming more and more clear. And as Valerio mentioned, we'll obviously keep everyone up to date as those discussions progress. But that is one of the things that we'll be discussing with multiple AI audio stakeholders in a research group in a couple of days.
Perfect. Okay. I'll ask one more question, and then I'll open it up for other people. I do have more, but I'll
go ahead.
Send them over afterwards.
Yeah, sure. So I'm curious. Because I'm looking at the metadata that you guys are generating, and I see a JSON object. So I'm curious if any person, for example, on a Mac OS Finder, could click on an audio file and then hit Command I to view metadata. So would that transparent metadata be viewable on a Mac OS Finder, for example? If I just click the file and hit Command I, does that make sense?
It depends. It depends on the viewer, first of all. So I'm not a Mac user. I can't kind of answer specifically to your question, but it really depends on the viewer, because generally, from in my experience, ID3 V2 tags are picked up by viewers in general, audio players, right? But then here in this case, we are also using custom ID3B tags. So sometimes they're picked up, sometimes they're not picked up. Okay.
Got it. Okay. Yeah. And so if you open it in iTunes, maybe you see it. There's tons of different viewers.
Yes. And the point for us is that we're not that much interested in having like transparency like at the level of the viewer, but rather like having a way of transferring this information to other companies. That's basically the idea, right? And then they'll be able to extract that information, most likely programmatically, right?
Perfect. Thank you. I'll open it up.
Fabian.
Hi. Thanks for the great presentation and what you've done so far. Incredible, and I like the roadmap and where it's going. I'm more interested in, you mentioned intercommunication between the programs that will be able to read the metadata. But as it stands now, I'll be able to watermark my audio and have it with me, and if I share it to other tools, then they'll be able to know that it's from me. But does this apply commercially if I generate a song and I want to distribute it, and then I want to check if it's still the same audio, or do I still own this piece of, do we still collectively own this piece of audio that was generated by me and the composers? Is it going to apply to the royalty collection aspects also, splits and everything? I just want to know how that will progress. It's a bit technical.
Yeah, so I'll speak to the watermarking side, and then Lucas, like if you want to just like take like the other part, like that has to do like more like with royalties, like that kind of stuff. So for the watermarking, careful, because TransparentMeta doesn't deal with watermarking yet, of course. It's only like digitally signed, cryptographically signed metadata. It doesn't do the watermarking for you, right? It's just metadata. Down the road, probably like 5 months from now, more or less, it could be a little bit less, it could be a little bit more, we're going to have the equivalent of TransparentMeta for watermarking, called TransparentMark. And then at that point, yes, you'll be able to watermark the information. But there's a slightly like different situation there, because in watermarking, you don't have like the same information capacity that you have with metadata, right? So you have like way less like space for information. So you're not going to have like all of that information that has to do with attribution, for example. So all of that will be living like on your data set, like on your database, for example, right? But you're going to have like a constant ID that you can use then to retrieve that information somewhere else, if that makes sense, right? And yeah, Lucas, like if you want to address like the other side regarding royalties.
Yeah. So it depends a little bit on where your file goes, right? So let's say, for instance, you've embedded the metadata in the ID3 tag through TransparentMeta, and you put I'm the composer, Fabian, and you know, the other kind of attribution information that you put in there. And let's say that you want to put it on Spotify, for example. Now, if you use a single musician distribution system like DistroKid, for example, yes, it will read the information in that file, and that attribution information will then go into Spotify, and it will be registered with all your details, and you know, depending on whether you're signed with a publisher, and so basically your royalties will be tracked to your original name. So it depends a little bit on how you want to distribute your content, right? But in that case, or if you use let's say CD Baby or something like that, in the Spotify distribution situation, it's really clear. Like a lot of those platforms read ID3 tags, and that attribution becomes clear. If you put it on Instagram, for example, it's less clear, right? Because that's not a DSP, it's not music specific. You know, I see you nodding, Diana. You might, you know, have some experience in this area. so it depends a little bit on where the distribution goes, right, and how the ingestion of the platform goes. But for music, and if you're using an audio aggregator, yes, for sure. If you embed your metadata via our library, it will go on Spotify.
Thanks a lot. What I just learned from you is that if I use something like DistroKid and I have the metadata embedded in the audio and I upload it to DistroKid, then automatically before distribution, the metadata is read by DistroKid.
Correct.
Oh, that's good to know. Thank you. Appreciate it.
No problem. Diana, you've raised your hand. I'll let you go next.
Can you hear me?
Yes.
Yeah. No, I was, the minute he told, I was thinking about social media, of course.
Right, of course.
So now you already said about a little bit about it, but what about, for example, other spaces that would be really timely to have this kind of tool? For example, YouTube. I'm thinking YouTube. I'm thinking Twitch, for example. Things that get cross posted across those areas.
Yeah.
And the other day I was talking to someone about like specific features of sound design that use, like, let's say this would be the perfect storm for this kind of situation. Like you have a specific piece of audio for sound design, and then you have also that it's being used like during streaming, let's say, on Twitch, and then posted on YouTube. Look, you have like the whole sort of food chain of the generated audio. So it's a really complex scenario, and
it's a very complex scenario. And to answer your questions, like standards for that type of provenance tracking and authentication don't really exist yet. Like these are a lot of disparate kind of technologies and big technology companies that want to have something proprietary, or they're not so interested in that, right? And that's one of the reasons why we've started Transparent Audio, because we want to like put together all these parts of the puzzle, right? So that that's why we have the idea of a company registry, of a key management system, so any service can prompt us via API and check the provenance along the chain. And that could be audio embedded in a video file and a Twitch stream. It could be a TikTok, YouTube, any of those. Currently, that principle doesn't exist, right? YouTube doesn't read ID3 tags, for example. So it's also about coming to a kind of consensus with the regulator, and then the tech companies, and also like putting these tools out there for the vast majority of creators and companies to use them and say, hey, well, this is for free. I tagged all my content with this. Maybe you want to read it or not, right? So it's like an ongoing discussion. Or do you have something to add, Valeria?
Yeah, I was just thinking, for example, since you are targeting like sort of company profile. So let's say I'm a producer and I'm also a streamer. It would be really nice for the watermarking sort of side of things for you to be able to somehow signal this usage of this material across like all this food chain. Just as a thought, because since none of these things can be interconnected, maybe I can do it from my own content posting side, so to speak.
Sure. I mean, again, it's up to the platforms, right? What data they display or choose not to display. Like you as a user can obviously put in parentheses in the title, made with AI, if you wanted, right? Doubtful that that's going to happen, but then it's up about just having this identifier data in the file in itself, and then it's up to the platforms to say, yay, we want to show it, or no, it's not interesting to us. I mean, ultimately, they're the gatekeepers of how content gets printed anywhere.
Yeah, I would just follow up to that answer, also saying that the legislation for now, like for our understanding of it, makes responsible of basically like labeling content the providers, not the platforms, right? So as long as the providers like put that label for the legislation is fine. But obviously there will be a huge problem down the chain if the platforms don't follow and don't actually read the labels and put them out. And this is like what basically we're trying to do, right? So we're building like, it's really like a trust layer so that everybody like can buy into it. And then hopefully also the platforms will, once they see that like there's a ton of audio companies that are using our layer, then they will be incentivized also to like read the labels and all the information and use us as the source of truth. Basically, yeah, that's what we are trying to do, right? So try to be like the ultimate source of truth for the provenance of this material, so that like deepfakes and AI generated content can't go in the wild without like any checks at all. So that's basically it. More questions?
Go, Jeff, go.
Go ahead.
Oh my goodness. Honestly, I don't know if this is helpful. This is just a hot take moment where it feels like what you guys are really trying to do is like when food regulations were born. It's, to me, it's kind of like that. Like, oh, make sure the food isn't moldy when you sell it, kind of thing. It's really like that. You need the companies to comply, like at a level to actually make that happen. Anyway, that's just my hot take. I'm curious, what audio features do you guys use or plan on using for your transparent detect solution? So it could be spectrograms, could be RMS, metrics, anything like that, if you're willing to share.
Yeah, we are willing to share because it's going to be open source. So we are willing to share, right?
Cool.
So for transparent detect, and I just want to like summarize like in 2 lines like what that is. So it's basically like an AI classification model that you can provide an audio file. It will analyze the audio file and it will give you a yes or no answer to the question, was this audio file generated by this particular AI model, right? So it's a classifier. We're going to be using machine learning. We're going to be using deep learning most likely. I can't tell you specifically what type of architectures we'll be using just because it's down the roadmap, right? And so I've obviously like I know like the literature like and everything, but this is like some R&D like that we will be doing later on. But most likely we will be using either spectrograms or MEL spectrograms because like that's the sort of like the golden standard for MIR and for classification tasks in audio. So yeah, we're not going to be using RMS. We're not going to be using like any of the other sort of like more like algorithmic features, but we're going to go directly to the perception layer. Yes.
Yeah. So pretty much just you're thinking just spectrograms for most part.
Or MEL spectrograms, yes.
Sure. Yeah. Spectrogram, I mean, to me, same thing kind of thing. Anyway, okay. And so when you say watermark, do you, and I might have asked this question to you guys before, so forgive me, but do you mean something actually baked into the audio file itself?
Yes.
Yeah,
yes.
Okay. Yeah,
that's basically that. So we're going to, once again, working at the spectrogram level, and we're going to basically sprinkle information in the spectrogram.
And with that, and you're thinking like between 20 to 24 kilohertz, so it would be imperceptible.
Yes. So this once again, like it's something like that will be kind of research, obviously, but in terms of the type of like method that we will be using, most likely we will be using like spread spectrum. That's one of the most robust algorithmic approaches. There's also like an option for neural watermarking, but the problem with that is that it is like very computational expensive,
Sure.
which basically makes it unusable in a semi-real-time situation where you have to verify things on the fly.
Wow. Yeah.
But just like to give you a little bit more context there, we're thinking of, so we're going to be having like this specification for watermarking. That's a semantic specification where you have like the bit stream. So basically what we expect to encode and how, right? But then we will be building the algorithm, so the spread spectrum algorithm. But on top of that, there will be a binding. And the binding can be like whatever you want. It could be like neural watermarking. It could be spread spectrum or whatever like other technique. As long as you follow the protocol, then you can swap in and out whatever actual implementation solution you want. So in this way, like we'll make it even more like plug and play and even more like of a standard, because as long as you follow the standard, then like say for example voices could like implement like their own version of watermarking, and as long as you follow the specification, they're fine with that. I don't know like how much like you will want to do that, but in theory like any company like could do that, because we basically provide the entire scaffolding for that.
Wow. And I'm assuming that this watermarking solution would be imperceptible.
Ideally, yes.
Of course.
Ideally, of course, like these are things that you have to try out, right? So
Yeah.
ideally, like, and in our like estimation, yes, but then like we'll have to do like the work. And by the way, like there's always like a trade-off.
Yeah.
There's a trade-off between like how perceptible it is and how robust it is. So it may well be that the solution is the same, and sometimes like it, depending on how like strong you want like the signal to be,
Yeah.
then it becomes like more perceptible. So it's a matter of like finding like the right trade-off between robustness and at the same time also perception.
Perfect.
Fidelity. Yeah.
Makes complete sense. I will stop for a second.
That's
Those
cool.
are all good ones. Yeah.
That's good. Do we have any other question?
Will you guys post this on LinkedIn when the recording is ready?
Yes.
Certainly, and on our
Yep.
YouTube as well.
And on YouTube as well.
Yeah.
Yes.
Perfect. Thank you. Just
That's
want to
cool.
share it internally.
Okay. Okay, thoughts. So I guess Lucas, that's it. I think like we've been quite comprehensive.
Yeah, no,
So-
absolutely. And you know, anyone with follow-up questions, hit us on my LinkedIn, email, you know, as you wish. We're always happy to chat, and you know, looking forward to input from people, right? Because you know, all this stuff is can be improved with your suggestions. So great.
So thank you very much for attending, and we'll see you next time. Take care.
Bye.